Electricity, transport and heating are becoming increasingly eco-friendly and sustainable. Renewable energies like wind and solar power already produce more than 30% of German electricity. But what about heat supply? Where does the energy for heating and hot water come from? Today's solutions are mostly based on burning fossil fuels: coal, natural gas and oil. In cities, heat is often supplied by district heating systems, each consisting of heat generators, distribution pipes, and consumers. The heat is transported by a carrier, usually water. Depending on system pressure, temperatures of 130 degrees Celsius and higher are possible. To achieve these temperatures, water is heated in power plants, then transported along flow pipes to consumers, where it heats buildings via radiators. The water is then cooled by the indoor air and carried back to the central power plant via return pipes, thus completing the cycle. Today, heat generators provide only as much heat as is required at any given time. They use gas boilers and combined heat and power plants, known as CHPs. Incidentally, these CHP plants don't only supply heat, but also electricity. However, they're usually powered by fossil fuels, which are harmful to the environment and therefore not sustainable. So how can sustainable energy sources help achieve a transition in heating? Solving this question is the objective of Smart Heat Grid Hamburg, a research project funded by Germany's Ministry for Economic Affairs and Energy. The project is a collaboration between Hamburg's University of Applied Sciences, the municipal energy supplier Hamburg Energie, and engl, a company specializing in the economic use of energy. The aim is to create a reliable, sustainable district heating system. To achieve this, the system has to be made more flexible and efficient. For example, on very sunny or windy days, photovoltaic systems and wind farms generate more electricity than is needed. Instead of switching off these plants, the excess electricity could be converted into heat and stored. That would make the system more efficient because storing heat is much cheaper than storing electricity. Energy is converted into heat using heat pumps or electric heating rods, so-called power-to-heat systems. However, challenges arise when other heat generators, such as solar thermal systems or CHP plants, also have excess heat to store. A future system will therefore have to be able to store particularly large amounts of heat. For this to happen, it will need to be flexible and allow both producers and consumers to cooperate intelligently. This will ensure a reliable heat supply even on cold winter nights. But Smart Heat Grid Hamburg is aiming even higher than that. The heating system should not only be more flexible, but also more efficient. One approach is to reduce temperatures. The lower the water temperature, the less heat is lost, and the more effectively renewable heat generators can be integrated. One possible way to do this is to connect older buildings with newer ones. Often, when heating water leaves older buildings, its temperature is still very high enough to provide heating for a newer building. By using the heating water twice, the temperature of the returning water can be lowered much more than usual, thus increasing the system's efficiency. Concepts like this are being used experimentally in the district heating system of the Hamburg district of Wilhelmsburg, where Hamburg Energie and engl are testing their feasibility. The concepts that are successful can then be implemented in larger heating systems. Integrating many different participants makes district heating systems very complex. In each system, there are heat suppliers and consumers. Some participants are even both, as they intermittently provide or consume heat. The innovative part of an intelligent heating system is the communication between the participants. All system information is fed into a central control unit where algorithms coordinate an efficient operation in real time. The research team is also developing a heat marketplace that brings participants together, allowing producers to offer heat and consumers to buy it. To manage the competition between heat suppliers, an algorithm analyzes supply and demand and decides which heat generator to use when. This way, heat generation, consumption and storage are coordinated at all times. Smart Heat Grid Hamburg aims to intelligently link available technologies in the district heating system and, in doing so, introduce a basis for the heating of tomorrow, a system that is both decentralized and renewable, more efficient and cost-effective. Thanks to this important contribution, the transition to sustainable heating can become reality.